In question 2 of this series, where we construct a truth table from a symbolic statement, this time our statement is shown right here, and we have to come up with the truth table and find the truth value of this particular statement. So let's understand this statement and see what these symbols mean. First of all, you see parentheses, and within these parentheses you have this tilde symbol that means not P. So we have a statement P, whatever that is. This symbol right here represents a conjunction, or and. So not P and R. This symbol, which looks like a V, is a disjunction, or. And after that we have parentheses, tilde Q, not Q, and not P. As you can tell, there are three different statements here, P, Q, and R. And using this formula, 2 to the power of n, we can find out how many different combinations there are. So if I substitute the number of statements, which is my n value, into here, I'll end up with 2 to the power of 3. This means that we'll have 8 different combinations for this particular table, or 8 different rows. Let's start by writing out P, Q, and R as columns, as dedicated columns. And one of the combinations is if all of these are true. A second combination is if these two columns are true and this is false. So true, true, false. We can also have true, false, true, and true, false, false. So those are 4 of the 8 rows. The other rows can look like this. And the order in which these rows are written doesn't really matter. I like to start off with trues and then finish off with the falses. So here we have false, true, true. Another one could be false, true, false, 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 and true. And lastly, all false. These are all the different combinations that can exist. Now, if you reread your statement, you start with parentheses, and within the parentheses, there is this negation symbol, not P. So I'll write that next, and notice that the logical operators are all written here, and they're written in order in which you analyze them. So first was parentheses, and then the negation symbol. In our case, it's tilde P. To fill in this column, you have to ask yourself, is P not P? P is true, so this is false. This will also be false, false, and false. In other words, is the P that we have telling us the following? It's not, because if it's true, it's actually going against what this is saying. On the contrary, take a look at this one. This time P is false, and that suggests that this is true. That's false, so this is true, true, and true. We've just filled in the 4th column. The next column will be these two together. So tilde P and R. So both have to be true in order for this to be true. So let's understand this. This is asking, is tilde P true? It's false. So just keep that in mind. And because it's false, we don't even care about R, whether it's true or false, because they both have to be true in order for this to be true. Therefore, I'm just going to leave this as false. Once again, is tilde P true? It's false. So I don't even care about R. This is automatically an F. So is this, so is that. On the contrary, is this true? It is. And R is also true, so we write down T. Over here, tilde P is true, but R is false, so it's an F. Both of these are true, and not both of these are true, so it's false. Let's continue reading our statement. Then we have this in parentheses, and within the parentheses we have tilde Q. We won't reanalyze tilde P because we already did in this column. So let's analyze tilde Q. Looking at here, is that not Q? We have a true statement here, so this is false. Do we have a not Q here? Because it's true, it should be false. On the contrary, we now have that Q is false, so this is true. False, true. True suggests that this is false. False, true, and true. And in our last column, we'll have tilde Q and, remember that symbol is and, tilde P. So both of these need to be true for this to be true. Is that true? It's not. So we don't even care about that one. automatically false. False. This is a possibility. This one is true and that one's false, unfortunately. Still doesn't work. True, false, another false, false. So we won't even analyze the other one. False. This one is true. And remember, tilde p was in the fourth column. That's both true. So this one is true. And the same thing can be said about these two. So we'll put down true. The final column should be the whole statement. And I'll just move this content over. So this time we're looking for either of these to be true. If one of them is false and the other one's true, it's still a true statement because it's or. They're separated by or. So starting over here, this one is false. It's okay. This one is also false. Unfortunately, neither of them are true. This one is false and that one was false. Same thing here, same thing here. This one was true and that one was false. Because one is true, that yields true. False, false. True, true, and true, false. That means it's true. Therefore, the truth value here is this row and these two rows. And there you have it. That is how to construct a truth table from a symbolic statement. Make sure you watch question 3 for another example.